Calculate the range of a projectile thrown at an angle of 60 degrees to the horizontal with velocity of 30 meters per second, and g is supposed to be 10 meters per second squared. Okay, this is the projectile. As you see, v0 is a vector with a size of 30 and the angle of 60 degrees with horizon. Okay, range is defined as the total horizontal displacement from the beginning to the end. It is a kind of delta x, and so I abbreviated it to be r. Okay, I remind you again that delta x is area under the graph of vxt. Okay, and vx is constant. Why? Because fx is 0. You know that no force is exerted on the object in horizontal direction. So ax is 0. We do not have any horizontal acceleration, so vx remains constant. This delta x, which is r, is the area under this graph, which is a rectangle. For finding the area of this rectangle, I'm going to find this width and this length. This width is easily the value of vx, and the value of vx is the horizontal component of v0, which is v0 cosine of theta. I substitute the values. v0 is 30 and cosine of 60 degrees is multiplied by 30 to give you 15 meters per second. So vx is 15. Here, for finding the t, we will have the other approach, which is plotting the vy against t. You know that vy indicates an accelerated motion because in vertical direction I have acceleration of negative g, which is in this case negative 10, and so vy is a line with negative slope, which could start from positive value, from 0, or even from negative value. But in this case, as you know, v0 has a positive component in vertical direction, and so vy at the beginning is positive, so it will start from the positive value. Okay, for completing this vyt, I indicate the v0 y component, which is v0 sine of theta here. Okay, substituting the values, 30 times sine of 60 degrees will give you 26 meters per second, and so at the beginning vy has been 26. Pay attention, I'm going to find this time. Okay, as the next step, I'm going to find this time, which is the time when the object reaches the top. Top is here, in which vy is 0, because at the top the object is supposed to go only horizontally, not vertically, because if it goes vertically, it is not the top. Okay, so here vy is 0. Here in this triangle, as you see, the height of the triangle is 26, and the base of this triangle is the time, which is my goal, which is t. Okay, slope of this line is 10. As I told you, this is the acceleration in vertical direction. So slope, which is 10, is height of this triangle, which is 26, over its base, which is t. And so rearranging this equation will give you t equals 2.6 seconds. This is the time at which the object will reach the top. Okay, pay attention to this track. From the beginning, which is the point A, to the top, the point B, the trajectory of the object is completely similar to the other part, from B to C. So left and right side of this trajectory are exactly the same, and so the time from A to B is equal to time from B to C. So from A to B is 2.6 seconds, and so from B to C is again 2.6 seconds more, so it will be 5.2 seconds. The total time of this travel. Easily, it will be the same time for Vx because the time elapsed in this travel is 5.2 seconds. Okay, easily the area under the graph of Vxt will give you the area of this rectangle, which is 78. I multiplied 15 by 5.2.